This is chapter 20, set B, exercise 3. This problem is confusing because it tells us we have a population of 100,000 people, and it tells us 60% are married, 10% have high incomes, and 20% have college degrees. Now that kind of sounds like they're talking about the same thing. These are actually completely different things they measured. It's not like some people are married or they have high incomes or something. They're talking about completely different things that they crammed into one problem. So basically this is 3 completely different problems talking about completely different things. So in part A, basically it told us up above that 60% of the people are married, and we want to find the chance that 58% or less in the sample of 1,600 are married. Now, first of all, you notice it's talking about percentages, like 60% are married, find the chance it's 58% or less. You know you're doing percentages, so we have to use all of our formulas for percentages. Now, it also says find the chance. Anytime it's saying like find the chance for percentage, you know that you're going to be doing our box models and all the things we've learned how to do about box models. So first, find the box model for people that are married. We're ignoring the high income and stuff. We are only caring about if they're married or not. And remember, when you're finding box models or percentages, it's because we counted the number of people. So you have like ones and zeros. So if 60% are married, we'd say like 60% are married with a 1. And then that would leave 40% with a 0 that are not. That's what the box model looks like. Now for the number of tickets in there, technically if you have 100,000 people, 60% of 100,000 is 60,000. And 40,000 people that are not married, because that's 60% of 100,000. Now that's confusing, or more confusing. That's a lot of extra work. That's what it technically should be, but you don't have to, because you can do anything that is equivalent. So you can do the 60,000, or you can just do 60% and 40% and save yourself a lot of worry. So we'll just leave it at 60% and 40% as our box model. Now, anytime we are doing percentages, we have these really nice shortcut formulas that we want to use. The book is not using those. They're making it sums, they're finding averages of a box, standard deviations of a box, expected value, standard error, and then converting to percentages. That takes a long time. Use our shortcut formulas. Okay, so we have our box, and we're going to draw 1,600 times, because that's how big your sample is. Okay, now expected value for the percentage is just equal to your population percentage. In our population percentage, 60% are married, so we just say 60%. Super easy. Standard error for the percentage is equal to the square root of our population percent times 100% minus the population percent divided by our sample size. Now, make sure you are keeping these percentages just as like whole numbers, because all of that's already accounted for. You don't have to try and change them to decimals. So the population percent of married is 60, and 100 minus 60 would be 40, and divide by my sample size of 1,600. Now, as far as putting this into your calculator, make sure you have really big parentheses around everything inside of there. Or if you didn't do that in your head, you could do 100 minus 60, just make sure it's in parentheses. The parentheses have to go around everything. Make sure the 1,600 divided by 1,600 is inside your parentheses. You might want to do it in multiple steps in your calculator. Like you might want to do the times first, then divide, and then when you're done, take the square root of everything. So that's what I usually do. So I'm going to do like 60 times 40 divided by 1,600, and then take the square root of it to get 1.224. Now, I stopped at 3 decimal places just because that's where I randomly stopped. You might want to keep at least 4 decimal places, at least 2. So this tells us that if I took a sample, I expect to get about 60% of the people in the sample to be married, give or take about 1.224%. I don't know exactly what I will get, but it should be about 60%, give or take 1.224%. Now find the chance that we are less than 58% when we take the sample. So anytime you're looking for a chance, you're going to have to find a z-value. Our z-values are all about the same, but instead of sums, we're just going to write a percent. So it'll be percent minus the expected value of the percent divided by the standard error of the percent. So the percent we're interested in is 58%. We're going to minus our expected value of 60% and divide by 1.224%. Now, when you put this in your calculator, make sure you put parentheses around everything on the top. So it should be 58 minus 60 divided by 1.224 gives me negative 1.633. Now, I always draw a picture at this point. So I'm going to draw a picture. Here is z equals negative 1.63. I'm looking for less, always means left. So let's look for the left area. I pull up my normal table. I look for negative 1.63. Looks like my area to the left is either somewhere like 4.95 or 5.48%. Just depending on which one you pick, you can pick either one. I have enough wiggle room on the exam that either one of those will be right. So let's just say 1.63 is kind of closer to 1.65, and I'll say 4.95%. So 4.95%. So about a 4.95% chance of picking a sample with less than 58% married.